Let's discuss circular motion in vertical plane. So far we have seen circular motion in which object moves in the horizontal plane like this. We have something which supports it so that it doesn't fall. That's a frictionless surface, and this object completes circular motion. If it's connected to a rope, then tension force on the rope provides necessary centripetal force. This time we are interested in circular motion which takes place in vertical plane like this. This is circular motion in vertical plane. You have to take care of mg also for vertical plane circular motion. Now, when you talk about mg, circular motion in vertical plane, then I hope you can realize that as it goes up, then due to gravity, speed of the object should decrease. That means we are talking about non-uniform circular motion. In uniform circular motion, we always have constant speed, which you can maintain in vertical plane, in the horizontal plane. But when object moves in vertical plane, because of mg, its speed will change. And if speed changes, then we deal with two types of forces. One is centripetal and the other one is tangential. Look here. We have an object of mass m. It is given some velocity u in this direction. This m is a point object. Length of the rope is r, and that's the center. It moves in this vertical circle when it reaches this point. Its velocity becomes v, and angular displacement it has covered is theta. Right here, tension force in the rope is T. And you know that tension always acts away from the body. It's a pulling force. T is acting like this. Downward force is mg. What's happening? You have this object. At the lowest point, some velocity is given in this direction. This velocity is u. And because of this velocity, it covers an angle of theta. And after covering this angle theta, its velocity becomes what? V. Right here, this rope is pulling this object. Pull is always away from the body. This pull is what T, and downward force is what mg. Our aim is to find the velocity of the object. We need to find v and tension force when object is at this angular position. V and tension force in terms of initial velocity u, angular displacement theta, radius r, mass m, and gravitational acceleration g. Now, as I told you, this is a case of non-uniform circular motion. When you talk about circular motion in vertical plane, it becomes non-uniform circular motion. In any type of circular motion, velocity always changes because direction continuously changes. But in non-uniform circular motion, magnitude of velocity that also changes. Initially it's u, after theta it has become v. Now, when you talk about circular motion, you talk about two forces. One is centripetal that acts in this direction towards the center. The other one is tangential force which acts in this direction. This tangential force is responsible for the change in the magnitude of velocity. And therefore, we should resolve all the vectors along these two axes. This for the centripetal one and this for the tangential one. If this is mg, then you can see that this angle is theta. This is theta, so is this. Tension force is already in this direction. Velocity is also along the axis. But mg is not present along the tangential axis and the radial axis. And therefore you must resolve mg. This component of mg is mg cos theta. Whereas this component is mg sin theta. So you can see that this mg sin theta is the tangential force, and since it is opposing the velocity, you can see it is basically producing tangentially retarding force. It's trying to decrease this velocity, and therefore if you find acceleration which is tangential acceleration, then it will be force divided by mass, at the same time this negative sign. Why negative sign? Because mg sin theta is opposing velocity vector. This will give us one equation. Second equation will come from the centripetal information. Now, there are two forces acting along this line. One is T towards the center, other one is mg cos theta away from the center. But we need centripetal force, and therefore this T must be greater than mg cos theta, which gives us total centripetal force as T minus mg cos theta. And what is centripetal force? mv square upon r. We'll get the second equation from this. There are two unknowns. We must have two separate equations. First, it's coming from the information of centripetal force Fc. Second one is coming from the information of tangential force Ft. These are the basics. Now, let's handle these equations. For the tangential equation, this is at. Now, what is tangential acceleration? dv divided by dt. That's tangential acceleration, which is minus of g sin theta. We need to remove this d part so that we can get v, and removing d is called what? Integration. But at this stage, you cannot perform this integration because there are three variables present: v, t, and theta. As this object moves, theta changes, and along with theta, v changes, and definitely time is also changing. Therefore, how to take care of this integration? What we do, we multiply v on both sides. We'll also see a second method which is much easier. You don't have to perform integration. We'll see that later. But in the first method, you will learn how to integrate these things. We'll multiply v on both sides. This side, when you write v, instead of writing v, you must write r omega. Why? You will see it. When this rope makes an angle of theta, right here, angular velocity is what? Omega. And everybody knows what omega is. Rate of change of angular displacement, d theta divided by dt. And we have this relation between velocity and angular velocity. V is what? R omega. This part and this part, they both are same. You can cancel them and you get the original information. Now this omega, you can write this omega as d theta divided by dt. dt and dt, they are cancelled and you got this information. V dv is minus of g sine theta multiplied by r into d theta. And there are only two variables present, v on the left side and theta on the right side. You can easily integrate this part. V dv, it's like x dx. Its integration will be v square divided by 2 minus of gr. What is this? Sine theta d theta. Sine theta, its integration is minus of cos theta. Remember, differentiation of sine is what? Cos. Its integration is what? Minus cos theta plus constant of integration c. When you integrate, you always go for constant of integration. Now, how to find this constant of integration? Look at this relation. This whole thing gives you v in terms of what? Theta. But you already know v at one place, which is the lowest position. At lowest position, theta is what? 0. When theta is 0 at the lowest position, you can see that velocity of the object is what? U. When theta, it's v. When theta is 0, you are at this position, v becomes what? U. This equation should satisfy this information. Let's put this information back into this equation. V, it becomes U. Gr theta is what? 0. What is cos 0? 1. You got 1 plus c. We have calculated constant of integration. V, replace it with u, theta, replace it with 0, and you get u square upon 2 as what? Gr plus c. You got the value of c as u square upon 2 minus of gr. When you put this c back in this equation, you get v square upon 2 gr cos theta plus c, which is u square upon 2 minus of gr. multiply 2, it becomes v square 2gr plus u square minus 2gr. 2 and 2 cancel, 2gr cos theta. This is cos theta. 2gr cos theta plus u square minus 2gr. That gives us v as root over u square minus 2gr 1 minus cos theta. V, this is square, take the root, it becomes what? U square, take minus 2gr common, take minus 2gr common, it becomes minus 2gr into 1 minus minus plus 2gr cos theta. This is an important result for vertical circular motion. We have obtained velocity in terms of theta. Let's see if this thing is correct or not. If I put theta 0, I should get v as what? U. If I put theta 0 cos 0, it becomes what? 1. 1 minus 1, 0. This part is gone. V is root over u square, which is what? U. This is velocity as a function of theta in vertical circular motion, which is coming as root over u square minus 2gr 1 minus cos theta. You should remember it like this. Now, we'll develop a second method for this equation, but if you put this v in this equation right here, then you will get tension force as m u square divided by r minus of 2mg plus 3mg cos theta. Nothing special. Take the value of v square, put it over here, and this t will give you mu square by r minus 2mg plus 3mg cos theta. Remember, we have got tension force in terms of initial velocity and theta. Again, a very important result for circular motion in vertical plane. We need two things, b and t. We have got these two things with the help of two equations. One with the help of centripetal, other one with the help of tangential. This first method was just to let you know how to perform integration. Multiply v on both sides because we cannot directly integrate this information. This is r omega. Omega becomes d theta by dt. dt is cancelled. This same technique we have done in motion in 1D as what? Acceleration as a function of position. If you wish, you can go and see the same thing. Right here, this acceleration is as a function of angular position, which is angular displacement. There, in motion in 1D, we have done acceleration as a function of displacement. Now, note down this much, and then we'll go for second method where we don't have to use integration, and that second approach you can use also in your school examinations. But first, note down this much. Remember, this is 2gr multiplied by cos theta. Now look at the second method. Velocity at the lowest point is u. At this position, it becomes V after it has covered an angle of theta. Now, throughout, there are two forces acting on the object, T and mg. These are the two forces which are acting on the object, tension force and gravitational force. If I ask you what is work done by tension force from this position to this position, and think about it. Now, look at this formula which we have developed in work, power, energy. What is power? F dot V. Or you open it, F into V into cos of theta. Not this theta. Theta is angle between force and velocity. So if I ask you what is power delivered by tension force, then I hope you can see that it's coming T into V into cos of what? 90. At any place, tension force, it's pointing towards the center. That means radial direction. Velocity is along the tangent. What is the angle between tangent and radius? This angle is always what? 90. And therefore, power delivered by tension force is throughout what? Zero. What is power? Rate of doing work. Since no power is there, work done by tension force should also be zero. Now what people do, they go for this displacement and all, then they multiply force into velocity, in force into displacement into cos of theta. That's not valid. Why? Because Fs cos theta is used when things are uniform. Right here, tension force is continuously changing its direction as well as its magnitude. And therefore, you will have to calculate with the help of dW, and this power is nothing but dW divided by dt. But since power is zero, that means rate of doing work by the tension force on the object is also zero. That gives you work done by tension force zero. Now, this mg, instead of using its work, we will be using its potential energy function. We have found work done by tension force is what? Zero. Mg will not go for its work, will go for its potential energy. Which means on this system there is no external work. Externally, force is present T, but it's doing no work. Mg, it's an internal force because we are using its potential energy function, and therefore there is no external work being done. And if no external work is done, we go for COME, which is conservation of mechanical energy. What is conservation of mechanical energy? Kinetic energy initial, potential energy initial, kinetic energy final, potential energy final. Now, what is kinetic energy initial? That's the initial point. Initial point. This is your final point. Your kinetic energy initially is what? Zero. Potential energy. We know that gravitational potential energy can be taken zero at any place. let's say at the lowest point, we have taken gravitational potential energy as what? 0. My fault, kinetic energy is not 0. Kinetic energy is what? Half mu square. It's moving with you. Initially, kinetic energy is half mu square. Potential energy is what? 0. At this level, the lowest level, we have taken gravitational potential energy as 0. Then, at this point, kinetic energy is half mv square and potential energy is mgh. H must be taken from that place where you have taken potential energy 0, which is this. That means from this level, from this lowest level, this object is at this much height. Our object is at this much height. We can find this h. Question is done. There is no need of integration. We just need to find this h. And this h is also a very simple thing. What is this whole height? R. This is also R. If you drop a perpendicular on this R from this point, then this much portion is the base component of this whole length, which is R, and therefore this part is R cos theta. Look here. This is R. This angle is theta. If you drop a perpendicular on this line, then this much is the base. This base upon hypotenuse, which is R, is what? Cos of theta. That gives you B as R cos theta. This is R cos theta. And the total height is what? R. What is H? This much. What is this? R minus R cos theta. So we found this H. This H is coming R minus R cos theta. Multiply whole equation with 2. Cancel m, and you get what? This becomes u square, v square, 2 is gone, m is gone. This is g multiplied by 2. You're multiplying with 2. 2 into g. In this h, we'll take r common. R 1 minus cos theta, and that gives us v as root over u square minus shift 2gr into 1 minus cos theta. Same result without any integration, just with the help of what? This concept of work, which we learned in work power energy. होपफुली क्लियर हो गई होगी कहानी किस तरह से आप इस सेकंड मेथड को यूज कर सकते हैं. This thing is something which you can use in your school examination also. But remember, the first method which we developed with the help of integration, that is also good. That increases your capacity to understand what internally is happening. This work and all, they are basically shortcuts. These things are good, but that integration part, ज़्यादा अच्छा है. Put down this much. Now, let's see some examples so that this circular motion in vertical plane becomes clear. Let's take first example. This is U, this is R, mass of the point object is M. Question says, find out minimum U so that object can complete 1/4 circle. Question is this, if I give it some velocity, then it only moves to this position. If I increase the velocity at the lowest point, angular displacement increases. The question says, what should be minimum U so that it can complete 1/4 circle? Note down the question. Find out minimum velocity at the lowest point. Find out minimum velocity at the lowest point so that object can complete 1/4 circle. Now, pause the video, try to find this answer, and then come back and see the solution. Well, we have information of V. V is root over U square minus 2gr 1 minus cos theta. That's your V. After it moves an angle of theta, that's the velocity in terms of initial and theta. Now when it reaches the 1/4 mark right here, you can see that angular displacement theta becomes what? 90. This is V, and if U is minimum so that it just reaches this position, then V should be what? 0. When you project it from the lowest point with U, increase it so that it just makes this point, this position, just able to reach this position. If you give enough velocity, more than the minimum required, then it will cross this position. If you give less, then it will reach this position somewhere and will come back. We need to give it some velocity so that it just is able to complete 1/4 circular motion. That means right here, V should become 0, theta is 90. Let's put these values in this equation. V is 0, root over U square minus 2gr 1 minus cos 90 is what? 0. Shift the root and you got U as what? Root over 2gr. This is the minimum velocity to complete 1/4 circle and is also a good result. Just write down like this. It's an important result. What is root 2gr? Minimum to complete 1/4 circle. Now, in the second part, we need to find tension force at this position. Right here, what is the tension force? T. Now, what's the formula for T? T is mu square by R minus 2mg plus 3mg cos theta. That's T. In terms of U and theta, that's the tension force. At this position, theta is 90. What is cos 90? 0. Minus of 2mg. U. To reach this position, U must be root 2gr. U square becomes 2gr. R cancelled. 2mg minus 2mg. That gives us T has what? 0 at this location. Let's look at this T with the help of this ball. Now, whenever rho is like this, there is no tension. It's taut. Tension is present. Slack condition. There is no tension. So, if I throw this object, it always maintains a tension force. But just look when it reaches this position. When it reaches the horizontal position, what happens? Look here. Right here, you could see that it was making this type of form. A slack is being created. That means tension force becomes what? 0. That's what physics also says. E is what? 0. Wrote down this part. Now the next question is, we need to find minimum u so that object can complete half circle. Write down the question. Find out minimum u so that object can complete half circle. We need u so that it can reach this position. It can complete half circle. This theta is 180 for half circle. Again, pause the video, try to find the value of minimum u, and then come back and see the solution. Now, to reach 1/4 mark, we put theta 90, V 0. To reach half mark, we'll put theta as what? 180. And since it's just able to reach the highest point, we'll say that V is what? 0 and theta is 180. 1 minus cos of 180. Cos 180 is minus 1. This gives us, cancel the root part, and you are getting u as root over 4gr. What is cos 180? Minus 1. Minus minus plus 1, 1, 2. 2 into 2, 4. U is coming what? Root 4gr. And I hope ज़्यादातर लोगों ने ये फाइंड कर लिया होगा that u is coming what? Root over 4gr. But the problem is this answer is wrong. What is wrong? At the highest point, we are saying that v is what? 0. This is something which is not possible. Now, what's not possible? Look here. When an object moves in a vertical circle, then look at the circular motion. Could you see that beyond this position, this thread lost tension force, but it never stopped. It kept on moving. Look again. It never stops. It keeps on moving. What happens if velocity is not sufficient? Then it simply does this. Look again. If you have sufficient velocity, then it will complete the circle. No issue at all. But as you decrease the velocity, you can see that it never stops, what happens? This rope, it loses what? Tension force. So what happens? If velocity is such that, if velocity is such that it reaches this position but is not sufficient enough, then it will lose tension and moves like this. It's not able to complete half circle. It is passing from this position. You increase the u. As you increase its velocity, it will reach somewhere here. Again, tension is gone. It moves like this. But it never stops. So what we say, if object is in the lower half, this is the lower half. Look at the lower half. If object is in the lower half, at the extreme ends, its velocity is 0. Last extreme end is this, of the lower half, which was the condition for 1/4 circle. If object moves such that it is in the lower half, tension force on the rope can never be 0. Velocity becomes 0 at the ends. Now, once you cross this lower half and you move in the upper half, its velocity can never be 0. That is because of this mathematical shape. If somebody is interested, plot a graph of v and theta and you will understand. But let's not go into that. Simply remember this fact: as it moves in the upper half, velocity can never be 0. Tension force can become 0. Write down this point. In vertical circular motion, if object is in the lower half, tension force can never be 0. In the lower half, tension force can never be 0, but velocity at the ends will become 0. If object is in the lower half, tension force can never be 0, but velocity at the end points becomes what? 0. And when object is in the upper half, its velocity can never be 0. But tension force may become what? 0. But tension force may become 0. And therefore, to complete half circle, that is to reach the highest point, tension force should just become 0 at the highest point itself. Tension force should become 0 just at the highest point. When at the lowest point velocity is minimum. We'll understand it. See, if I give it root 2 gr, previous example, then it will reach here. If velocity is less than root 2 gr, it will oscillate in the lower half. If u is root 2 gr, it will cross the 1/4 mark. If u is more than root 2 gr, it will cross this 1/4 mark. Once it crosses 1/4 mark and reaches upper half, V can never be 0. But if velocity at the lowest point is not sufficient enough, then tension force will become what? 0. If you want it to reach the highest point, then you should be such that just at the highest point, T becomes 0. But since it has already reached the highest point, question is done. If T becomes 0 somewhere here, then the moment T becomes 0, V is present, it will move. T is 0. Now there is only one force, which is what? Mg. Under mg, path is what? Parabolic. It's no longer circular. And we need circular path, and therefore we increase the velocity. But now what happened? It lost tension at this position. Again, under mg, it moves and follows a parabolic path. If you want it to reach the highest point, throw it such that just at the highest point, T becomes 0. And the moment it is at the highest point, look at the interesting part, it can continue the other half, this portion, automatically. You just need to make it reach the highest position. If it is able to reach the highest point, then the other part, it can complete automatically, and therefore U minimum to reach the highest point will be same as minimum U to complete full circle. Otherwise, for U greater than root 2 GR, if it lost tension somewhere here, then look at the path. This point onwards, its path is simply parabolic. That means in the question, this assumption that the highest point your V is 0 went wrong, and therefore this calculation is not correct. Which means when U is minimum, instead of saying V is 0, which is wrong, we must say tension force T at the highest point is what? 0. What's the formula of T? T is mu square by R minus 2mg plus 3mg cos theta. T has become 0. We need to find U minus of 2mg plus 3mg. Theta is 180, cos 180 is minus 1. Cos 180 is minus 1. M is cancelled, M is cancelled, M is cancelled. This is minus 2. This is minus of 3. That gives you minus 5. Shift it and you get U as root over 5 GR, which is the correct answer. This again is an important result. Remember, this U is what? Minimum. Anything above root 5 GR, this object will never lose tension. Tension will be always present. In this situation, U is sufficient. It's greater than root 5 GR, and therefore tension force nowhere becomes 0. But U less than root 2 GR, that's what is happening. U root 2 GR, it reaches the 1/4 mark. U greater than root 2 GR but less than root 5 GR, it moves somewhere here, and then it completes a parabolic part. U root 5 GR, it just reaches the highest point and then automatically completes the other part. U greater than root 5 GR, it will continue doing this vertical circular motion. Now write down the statement. If velocity at the lowest point if velocity at the lowest point is between root 2 gr and root 5 gr. If velocity at the lowest point is between root 2 gr and root 5 gr, then object cannot complete full circle. It will cross the 1/4 mark. It will cross the 1/4 mark, and after that, somewhere it will lose tension force, and after that, since only mg is acting, its path will be parabolic. Its path will be parabolic, something like this. It moves like this, follows the circular track. Right here, tension is gone, and then this path is parabolic. This much till this point. Till what point? T becomes 0. Somewhere here. Till this point, path is what? Circular. But after parabolic, because only mg is acting, T is gone. This happens when your u is less than root 5 gr and is greater than root 2 gr. Between these two boundaries, that's what happens. Before that, you already know, it remains in the lower half. After this, you know, it's able to complete full circle. Now remember an important thing. Mostly people remember this result in incorrect form. They think that whenever vertical circular motion takes place, velocity at the lowest point is root 5 gr. No. Minimum velocity to complete half in terms of half, or you know that full, is root 5 gr. Anything beyond, it will be able to complete full circle. Write down this also as a statement. Minimum velocity at the lowest point, to complete half circle or full circle. Once half is done, automatically full is done. To complete half circle or full circle is root 5 gr. Now, we found that V at the highest point is not 0. Let's go and find what it is basically at the highest point. Again, write down this as a question. When object is just able to complete full circle, when object is just able to complete full vertical circle, find out its velocity at the highest point. Find out its velocity at the highest point. Pause the video, go for it, and then come back and see the solution. Now, we need velocity at the highest point. That means we need this formula, which gives us u and theta. What is u? Root 5 gr. What is theta? 180. That's what these values here. V is coming root over 5 gr u minus of 2 gr 1 minus cos 180 is what? Minus 1. 1 minus minus 1, 2. 2 into 2, 4. V at the highest point is coming root GR. हमने क्या लिया हुआ था? 0. Therefore, it was wrong. Remember this also as a result. All these are important results. But remember, at the highest point, velocity is root GR. Only if at the lowest point, it's what? Root 5 GR. If you will increase it, this thing will also increase. If you decrease it, it will not reach the highest point. It won't be able to complete full circle. It will follow this trajectory, which is part circular and part parabolic. Note down this much.